Hey guys, welcome to EduKaji. If you guys are first time here, allow me to introduce myself. So my name is Walter and I'm a chemistry tutor as well as a real life scientist. So this particular video will be discussing about a past trial paper for the KSSM Chemistry syllabus. So without further ado, let's jump right into it. Okay, all right. So this is the trial state paper for Perlis 2022. So without further ado, let's take a look at the question. So for the paper 2 is divided into 3 different sections, which is section A, B, and C. So currently we're at paper 2, section A. So let's take a look at the first question. So diagram 1 shows the electron arrangement of water. What is the purpose of chemical bond formation for A? The answer is very simple: to achieve octet electron arrangement. Okay, duplet or octet lah, because hydrogen is duplet, oxygen octet. So let's put here to achieve state. It's supposed to be to achieve stable electron configuration. Okay, just so you guys know. So let's put here to achieve duplet or octet electron arrangement. So that will technically give you 1 mark. So let's go to the second question. B, state the type of particles in water. So usually waters form what we call as molecules. Okay, so let's put here molecules. The answer is molecules. You get 1 mark from that. State the type of chemical bond in water. So if you're talking about chemical bond in the water itself, because it says in water, there are 2 ways you can say it, either in, or they can actually use the term between. Okay, so if it's in water itself, means within the water molecule, and if it's within water molecule, then it should be somehow referring to the covalent bond. Unless they say between the molecules, then of course it's going to be hydrogen bonding. So for this part over here, let's put there covalent bond. You get 1 mark. Based on diagram 1, explain the chemical bond that is formed. So you can just say here, 1 oxygen atom actually shares 1 electron each with 2 separate hydrogen atoms. And in terms of electrons, that should give you 2 marks already. So you say over here, 1 oxygen atom shares 2 electrons with 2 hydrogen atoms. This is referring to 1 each, okay? 1 electron each. And then you say that 2 hydrogen atoms will also share 1 electron each with the 1 hydrogen atom. Sorry, with 1 oxygen atom. So that should give you 2 marks in total. So this is actually explaining how the electrons are being shared. So 1 oxygen atom actually shares 1 electron each with 2 separate hydrogen atoms. Okay, so that's why they got 2 electrons being shared with 2 hydrogen atoms, and then both the hydrogen atoms also must technically share 1 each with oxygen, so that both of them can achieve stability through that particular electron arrangement. So let's look at number 2. Diagram 2 shows the apparatus set up for an experiment to investigate the electron transfer. at the distance in the redox reaction. So you can see over here that on the left side, we have iron 2 sulfate solution. And then on the right side, we have acidified potassium manganate 7 solution. So one will act as an oxidizing agent and the other one will act as a reducing agent. So state the color of the iron 2 sulfate solution. So since it's an iron 2 ion being present, that should be supposed to be green in color. Okay. So iron 2 is green, iron 3 is actually brownish in color. So for this case, you just write here green. You should be able to get 1 mark straight away. When the circuit is completed, the galvanometer shows a deflection, state the type of reaction at R electrode. So I will say electrode R over here, since acidified potassium manganate 7, it's a very good oxidizing agent. Okay, so this one must be your reducing agent. Okay, and since this is the reducing agent, then electrode R technically will undergo oxidation reaction. While at this side over here, you should undergo reduction reaction. Okay, so the type of reaction that you'll be able to see here will be technically oxidation. So writing oxidation will give you 1 mark straight away. Let's go to C. Referring to the reaction that takes place at electrode S, which is referring to the reduction part, state the observation for the acidified potassium manganate 7 solution. So in the electrode S, what happens is that the potassium manganate 7 has a Mn7 plus ion, which is technically purple in color. And then after that, it changes into Mn2 plus, which is now technically colorless. Okay. So what will happen at the electrode S will be that the solution will turn from purple to colorless. So you say here, solution changes from purple to colorless. Okay. Then state the change in oxidation number of manganate ion or manganese ion, actually, sorry, manganese ion. So you can just say here from 7 plus or from +7 to +2. Okay, from 7 to +2. There you go, 1 mark straight away. Just like I explained to you just now, okay? So if you don't know how it works, pretty much it's very simple. It's going to be MnO4 minus plus 5 electrons. And then you have to add on another technically 8 hydrogen ions, okay, for the formation of water. And then what you'll get is very simple. It's going to be Mn2 plus a total of 4 water molecules. So that's how the Mn7 plus from here changes to Mn2 plus, because if we check the charge of Mn, right, in this manganate ion is supposed to be Mn7 plus. So Mn7 plus is changed to Mn2 plus through that particular method. So that's why it accepts 5 electrons in total. So that's a half equation for electrode S. So draw the arrow in diagram 2 to show the direction of electron flow. It's very simple. Since electron is being accepted by the manganate ion, so the electron flow should be, you can just put either something like this. Okay, but if you don't want it to be too ugly, you can actually show something like this. Okay, just show the electron flow. We'll just put here electron flow. Because this says show arrows, so you already show the arrow. So this is the easiest way to represent the movement of electrons. So that technically score you 1 mark in total. Okay, so number 3. Propane and butane are hydrocarbon compounds which have a molecular formula of C3H8 and C4H10 respectively. What is the meaning of hydrocarbon? So hydrocarbon are compounds which contains only carbon and hydrogen. So you must write it down. Compounds which contains only the element carbon and hydrogen. As long as you got the word carbon and hydrogen and only, you should get 1 mark already. Okay, no matter how you phrase it lah. So I say here compounds which contains only the element carbon and hydrogen, which indicates that inside my compound got only these 2 elements. Then you get 1 mark. All right, the empirical formula of butane. So I think butane in the simplest whole number ratio among the 2 atoms, it will be divided by 2, okay? 4 divided by 2, and then H divided by 2 as well. Then you get C2H5. So this is the outcome, C2H5. So you get 1 mark from there. B1, combustion of propane gas in excess oxygen will produce carbon dioxide gas and water. Write the chemical equation for this reaction. I think that's pretty simple. So you can just put here, the formula will be C3H8 plus 5O2. And then you'll get 3CO2 plus 4H2O. So 1 mark comes from writing the correct formula for every single substance over there. And another mark comes from balancing the chemical equation. So therefore, if you balance correctly and also you write the correct formula for each substance, you should be able to get 2 marks from here. And number 2, if 0.5 mole of propane gas completely burn in excess oxygen, displaying the volume of carbon dioxide gas release in room temperature conditions. Okay, so again, if you see the if you take a look at the equation, for every 1 mole of propane, it combusts with 5 mole oxygen to give you 3 moles of carbon dioxide and 4 moles of water. Since what they want right now is to determine the volume of carbon dioxide gas release when you have 0.5 mole of propane being combusted. So in terms of ratio, it'll be 1 to 3, which means for every 1 mole of propane being burned, you should have 3 moles of carbon dioxide. But since the question only say that you have 0.5 mole of propane, so you only have like 1.5 over here in terms of ratio. So 0.5 times 3 is technically 1.5. So what I can do here is very simple. You just write propane's formula, and then you put a to CO2 ratio. So this will be technically 1 to 3, right? So number of mole of propane to carbon dioxide is 1 to 3. So that will be 0.5 to 1.5 mole. So then after that, you can just put here number of mole of carbon dioxide is 1.5. So right now, to calculate the volume of carbon dioxide gas produced will be 1.5 times 24, right? So just put here 1.5 mole times 24 decimeter cube. You should be able to get 36 decimeter cube of gas. Now the question did not actually ask you to write anything specific in a specific unit, so you can write either in dm cube or cm cube. It doesn't actually really matter. It's entirely up to you. So that's pretty much for that particular question. Let's move on to the next one. Number 4, diagram 3 shows an experiment to determine the heat of precipitation. Excess magnesium powder is added to 50 cm cube of 0.5 mole per dm cube of copper 2 nitrate solution in a polystyrene cup. Then I give you the specific capacity of water, which is 4.2 joules per gram per degree Celsius. And then density of solution is 1.0 grams per cm cube. So here, before the experiment is done, the initial temperature is 29. And after that, after the reaction is completed, the temperature is 56 degrees Celsius, which shows you that there's an increment of temperature. Okay. And also the fact that this is actually an exothermic reaction. Okay. So let's take a look at the next question. So A1, state the meaning of heat displacement. So heat displacement is the heat change or heat release when 1 mole of copper is displaced by magnesium in the copper 2 nitrate. So you put over here heat release. When 1 mole of copper is displaced by magnesium in copper 2 nitrate solution. So you get 1 mark. So that's the definition-based question. Okay. Based on diagram, state the initial temperature of copper nitrate solution in the highest temperature. So initial temperature of the solution should be technically 29 degrees Celsius, and the second one should be 56 degrees Celsius for the highest temperature achieved. They get 2 marks over here. All right, then I ask you to write an ionic equation to represent the reaction that occurred. So this is referring to overall ionic equation. If we don't know how to write overall ionic equation, then you have to write 2 separate half equations first. So the first half equation is when magnesium dissolves into the solution, all right, forming magnesium ion, and at the same time it releases the electron. So right now, then after that, the electron will be accepted by copper, right? So copper 2 plus will accept the electrons to form copper atoms. So once you get these 2 half equations done already, you can just cross off the electrons on both sides. And then after that, to write this overall ionic equation is very simple. Whatever that's before the arrow, you put together. So in this case, you just put here Mg plus Cu2 plus. And then after that, whatever is after the arrow, we put together as well. So here will be Mg2 plus and copper. So that will be your overall ionic equation. Just use the half equations technique to easily identify the overall ionic equation. Calculate the heat of precipitation in this experiment. So we're going to use 2 different formulas over here. The first formula we're going to use will be Q is equivalent to MC theta. And then the second formula we're going to use will be delta H is equals to Q over N. So right now Q will be, M will be the total volume of solution. So in this case here, it will be 50. Okay, so 50 grams multiplied by the constant, which is 4.2, multiplied by the temperature change. So 56 minus 29, you can just use your calculator. So that would be around 27. So that would be very simple. And that will be, if you calculate properly, it will be 5670 joules. And you have to convert it to kilojoules before you calculate the delta H value. So I will do that first, okay? So the energy heat change will be 5.67 kilojoules, right? And then the second part here is to get the N first, because you got to get the Q, right? You got the Q already. This is the Q. So our job now is to get the N before I can use the second formula. So N here will be very simple. N will be referring to MV over 1000, which is molarity times volume divided by 1000. So now what we have over here is the concentration and volume is given. So 50 and 0.5. So that will be technically 0.025 more. Okay, then you can substitute the value in now because you got two values already, right? You got N, you got Q as well. So now delta H is equal to Q over N. So our Q will be 5.67 kilojoules, and that is divided by number of mole, which is 0.025. Then finally, if you calculate properly, you'll be able to get minus 226.8 kilojoules per mole. However, be very careful. The reason why is because sometimes students get the correct answer, but they did not put the negative sign. So negative sign here is to explain to the examiner that the reaction is actually an exothermic reaction. So exothermic reaction means release heat to the surrounding, and it must be a negative delta H value. So make sure you write down the negative symbol, or else it's going to be wrong and you won't be able to get marks. So therefore, if you get all correctly, this is supposed to be a total of 3 marks. Okay, let's go to number 5. Table 1.1 shows the composition and the uses of the 3 types of alloy. So R, we have copper and tin, which is used to make trophies. Brass is 70% copper and 30% zinc, which is used to make keys. Duralumin, which is 93% aluminum, 3% copper, 3% magnesium, and 1% manganese, is used to make the body of aircrafts. So based on that particular table, name R. So R should be bronze. Right, the combination will tell you that it is actually bronze. And state on the use of alloy in 5A, or state on the use in bronze, you can just say here to make metals. Because sometimes metals is made out of pure bronze. So that's one of it. Right, next, B. AMAC is National Cyclist Suggested type of alloy that is suitable to manufacture AMAC's racing bicycle. Give your reason. So I'll say here duralumin is the best because when you are in a race, you need to make sure that your vehicle is as light as possible. So you can put here duralumin because it is light and stronger, or just light and strong. So therefore, you get 2 marks over here. Very simple. Okay, so one answer, one suggestion or answer, you get 1 mark, and then the explanation here will be another 1 mark. Okay. Now, you are given a bronze key and a brass key. Every key is the same mass of 140 grams. Calculate the mass of copper on in each of the keys. So I think it's very simple. Currently we have different composition, I would say. Yeah? So let's take a look at this. So for bronze, right, it is 90% of copper. Okay, 90% of copper. So then imagine now we have 140 grams of mass of each key, 1 bronze, 1 brass. So what we need to do is that for bronze, so for bronze key, it will be 90, 180, sorry, 90 over 100 times 140, which is indicated by over here. Then you'll be able to get 126 grams. And then for brass, okay, for brass, so for brass key, very simple. For the brass key, you can just take 70, because the composition is 70, right? So 70 divided by 100 times 140. Same thing also. You can see that the percentage of the bronze key, copper and bronze key is higher compared to for the brass key. So this is the answer for both sides. Okay, so if you get it correctly, you should be able to get 2 marks in this case. For D, diagram 4 shows apparatus setup used in an experiment to compare the hardness between bronze and its pure metal. So when the weight is dropped on top of the steel ball or a pure metal ball, it will then cause a dent. So the larger the dent being produced, the harder the indication alloy is there lah. So you have two different types over here, copper and bronze, which produces a diameter dent of 0.8 and 0.6. The higher the dent, right? The higher the diameter of the dent, that means the metal is weak, right? Or it's more malleable or more soft compared to the bronze or to any alloys. They're technically harder, so they should have a smaller dent being formed. Okay, so explain the difference in diameter of the dent form. I think it's very simple. You can just say that. Let's see. You can actually say that in copper, the atoms are arranged in a regular manner, so it can actually cause the atoms to slide. So you say in copper, in copper, the atoms are arranged in layers in a regular manner. And the layers of atom can slide, slide. Another you can say here, while the bronze bronze is an alloy that does not have a regular arrangement of atoms. Okay, so that is 2 marks in total. Should be all right. So of course, you want to extend a little bit. You can see here the layers cannot slide. So can okay, upon application of force. We'll give you 1 mark each for the explanation. All right. So let's move on to the next part, number 6. Table 2 shows the relative atomic mass of a proton number of 4 elements, so 16, 23, 24, 35.5 for oxygen, sodium, and magnesium, chlorine, respectively. And then a proton number 8, 11, 12, and 17. What is the meaning of proton number? It says the total number of protons in the nucleus of an atom. Okay, so the total number of protons in the nucleus of an atom. So you get 1 mark. And then magnesium reacts with oxygen gas to form magnesium oxide. Write the chemical equation for the formation of magnesium oxide. Here it's pretty simple. That will be 2Mg plus O2. You'll be able to get 2 magnesium oxide. So balancing the chemical equation 1 mark, and the correct formula will also give you technically 1 mark. Okay, sodium and chlorine react to form a compound. Draw the electron arrangement for the compound. So when they say draw electron arrangement of the compound, you must draw the atomic structure, but only for the final product, not for the initial one. So we know that initially sodium has electron arrangement of 281. And then after that, chlorine has an electron arrangement of 287. So that's easier for them to make a transaction. Okay, so sodium donates one electron away to chlorine, and then after that, what happens is that sodium becomes sodium ion and chloride becomes chloride ion. So how it looks like is very simple. You can just write Na and then put a circle around it. Okay, then after that, you can see that sodium itself has only two shells, but the two shells are fully occupied. Or you may say that it's actually a octet electron arrangement. So then you just put a plus sign over here to show that it is an ion. And after that, the other one will be very simple. We have chloride. So the first one's over here. Okay. Okay, all right. So after that, what we do is we're going to bracket over here, just like for sodium. Okay, we'll draw a better one. This looks a bit ugly. Okay, and after that, you put a minus over here. Done. Then the rest you can either put cross or dot if you want to. But usually what happens is that we know that one of the electrons should come from the sodium. So for one electron alone, we just put a circle just to indicate that it came from sodium, technically. So in exam, you're allowed to use the cross or dot diagram. It's called a cross or dot diagram. Circle, black color circle is electrons, and then the crosses is also for electrons. So 2 marks in total to explain how the product is being formed. Still the type of compound form. So the answer here, very simple, is actually ionic bond. Okay, so you put here ionic compound. Okay, so 1 mark. And then predict the physical properties of the compound form. Predict the physical properties of the compound form. I would say here, where the symbols of MEM all will be high melting point. Okay, high melting point because it's hard to separate them as the ions are held together by strong electrostatic force. So that's the answer. Okay, all right, next D. If 1.2 grams of sodium metal reacts with excess chlorine gas, calculate the mass of sodium chloride produced. So right now it says here we have the particular metal, right? In this case would be sodium, I guess. Okay, so right now what we need to do is the first thing to do is to calculate number of mole. So that will be technically 1.2 grams divided by which is the molar mass of sodium, which is technically 23 grams per mole. So what you'll get is then 0.052 mole. Okay, 0.052 mole. Okay, then after that, what happens then you need to find out what's the MR of your chlorine. Now, before that, take a look at the question. So how are we going to calculate the amount of sodium chloride being formed is very simple. So the equation is very simple. You can just write here. Na plus Cl2, you get 2 NaCl, right? So for every 2 mole of sodium, okay, for every 2 mole of sodium, you get 2 mole of sodium chloride. So MR of sodium chloride will be 23 plus 35.5. Okay, 23 plus 35.5. So that will be around 58.5. So that's the sodium chloride MR. And then we compare in terms of ratio, right? In terms of ratio, the amount of sodium corresponds to the amount of sodium chloride. So it's a 1-to-1 ratio. So then after that, what we're going to do next will be very simple. You just have to multiply it. So right now, the number of mole of number of mole of sodium chloride will be 0.052 mole multiplied by 58.5. So then it will be technically 3.042 grams. Right? So this is pretty simple. If you get everything correctly, if you were to measure correctly, calculate correctly, you should be able to get 2 marks from this particular question. So that is for that's for D. Okay, let's move on to the next question. Okay, so let's take a look at question number 7. So diagram 5 shows the preparation of an insoluble salt. So we have 25 cm cube of 0.5 mole per dm cube of sodium sulfate solution, added to 25 cm cube of 1.0 mole per dm cube of lead-2 nitrate solution. So the precipitate X that's being produced over here should be lead-2 sulfate, supposedly. Right, and then they ask you to name the reaction above. So when you add 2 soluble salts together to form an insoluble salt, usually what we get is insoluble salt, and that process is called as double decomposition. So for this question over here, the answer is double decomposition. So that will technically give you 1 mark. And then let's go to B. So B over here, name the precipitate form. So I already explained to you earlier that the precipitate is known as lead-2 sulfate. Okay, that will give you technically 1 mark as well. Let's move on to the next one. So the ionic equation for the precipitation is Pb2 plus SO4 2 minus, you get PbSO4. So calculate the precipitate form. I think that's pretty much very simple. So you need to ask yourself and see what is the number of mole of sulfate and what's the number of mole of lead in this case, right? So you can see there are 2 different concentrations over here. If you want to know the concentration of sulfate, you must understand that the formula for this compound over here will be NaSO4. And then for this one here will be PbNO32. Okay. So we know that in this case, right, when sodium sulfate decomposes to form sodium ions and sulfate ions, you'll technically get 2 times sodium ions. Okay, and then you will then get 1 time the sulfate ion. So to calculate number of mole of sulfate ion, number of mole, it will be MV over 1000. So if you were to use MV over 1000 over here, you technically get 0.5 multiplied by 25 divided by 1000. So then you should be able to get 0.0125 mole. Okay. So 0.0125 mole of sulfate ions. So this is your first part of the calculation. And then for the lead-2 nitrate ion, okay, you must see the lead-2 nitrate. So lead-2 nitrate will give you 1 times lead ions. In this case, 1 time lead ions. And then you'll also get 2 times nitrate ions. But we will focus more on the lead. So for whatever you calculate here will be 1-to-1 ratio. So to get the number of mole of Pb2 plus,
you'll also be using MV over 1000, and that will be 1 times 25 divided by 1000. So the answer here will be 0.025 mole. Okay, so supposedly we see the chemical equation here, the ionic equation. The ionic equation shows you that for every 1 mole, you get 1 mole, right? So you must have a 1-to-1 ratio to form lead sulfate. But if you see properly in this question, right, you actually get an even number of moles of lead and also sulfate ions. And if you see, I would say that the amount of lead ions will be higher compared to the sulfate ions, right? Because we're comparing in terms of mole is 0.025 and 0.0125. So the number of mole of sodium sulfate is, I would say half of that of lead nitrate. So which means now your lead ions are more than the sulfate ions, okay? If you can't see it, let me just show you. So we're talking about ratio right now, right? So the ratio between lead ions to sulfate ions is technically 0.025 to 0.0125. So in terms of ratio, we see probably it is 2-to-1. But the ionic equation only shows you that we need 1-to-1 ratio, which means we have excess amount of lead ions compared to sulfate ions. So what we're going to do is that we're going to standardize it. We're going to follow the amount of number of mole, the same as sulfate ions, to get the maximum amount of products. So in this case, let's take a look at the question. So they say calculate the mass of precipitate form. So since the ratio of lead ions to sulfate ions must be equal, so we must follow back 0.0125 to 0.0125 mole. Sorry, let me just correct that. Okay, so now we'll calculate the MR of lead sulfate. So that will be 207 plus 32 plus 16 times 4. So let's see how much we get. So 207 plus 32 plus 16 times 4 would technically give us 303. So right now, since we have number of mole over here and they have the MR over here, so the mass of precipitate form will technically be number of mole, which is 0.0125 multiplied by 303, which is the MR. So your answer is supposed to be 3.79, approximately 3.79 grams, if you run it after the two closest two decimal points. So therefore, this question, if you answer everything correctly and you show all workings in terms of the top one as well over here, then you'll be able to get a total of 3 marks in this case. All right. Now let's move on to the next question, D. The diagram 6 shows the flow chart, a series of reaction of copper to carbonate salts. Copper to carbonate reacts with sulfuric acid to give you salt L, carbon dioxide, and also water. And that ends up with the reaction number 5, okay? So then you got a blue color precipitate form, insoluble in excess NaOH. So what happens here is that your salt that's being produced here is supposed to be copper sulfate, okay? Copper sulfate, because why? Copper carbonate will react with the sulfuric acid to form a sulfate salt. So therefore, the answer here will be copper to sulfate. Okay, and then I asked you to write a chemical equation. I think that's pretty simple as well. So right here, CuCO3 plus H2SO4. You'll be able to get CuSO4 plus CO2 plus H2O, right? So you must be able to write all of the correct formula and then balance the chemical equation, then you'll be able to get 2 marks. It's pretty simple. Okay, let's move on to the next one. Number 3, a pupil wants to convert salt L back to copper to carbonate. Explain briefly how salt L can change back to copper to carbonate. So how we're going to make back copper sulfate to get back copper carbonate. So you have to use back the same idea of the double decomposition lah. Okay, we can add 2 soluble salts together to get you back the copper to carbonate. So in this case, I'll give you the equation first. Okay, this is the equation. So what you can do is very simple. Your copper 2 sulfate, you can add with any carbonate salt that's soluble. In this case, you have 3 choices. You can either use sodium carbonate, or you want to use potassium carbonate, or ammonium carbonate also can. Because we know that all salts of sodium, potassium, and ammonium are soluble. So in this case, let me just use sodium lah, easier. So sodium carbonate can be used as your answer as well. So you got Na2CO3, and then what you'll get is, again, a precipitate of copper carbonate, and you'll get Na2SO4, which is soluble. So this is how you get your copper carbonate. Again, you can actually substitute this one with K2CO3, or you can also use NH4 to CO3. So any one of it should be correct lah. So how are you going to explain that in your answer? In number 3 over here, you can just say that add solution L to sodium carbonate and a precipitate will form. Okay, so that's how it works. You get 2 marks over here. So if you answer all correctly, you should get a total of 10 marks in this question lah. Okay, let's move on to number 8. Diagram 7 shows the part of the periodic table elements A, B, C, D, and E are not the actual symbols of the element. Okay, now which element is a halogen? So halogen is usually located at group 17. So this is supposed to be group 17, and this is supposed to be group 18. So you can just put here element E. Okay, just put E also, you get 1 mark already. State 2 elements which are placed in the same group. Same group means same vertical lines lah. So the only possible one that's the same vertical line will be A and D. So you can put here A and D. Okay, you get 1 mark also. All right, so B, 0.1 mole of iron wool reacts with excess chlorine gas. Balance chemical equation for the reaction. So you can see here, iron wool reacts with chlorine gas, you get FeCl3. So I think you have to put a 2 here, and then you're going to balance it up here, and then you have a 2 here as well. Okay, so that will give you a balanced chemical equation, which will then give you 1 mark in total. Okay, and then let's move to the next one. So calculate the mass of the product form. So right now we have 0.1 mole of iron, 0.1 mole of Fe. Okay. So if you see closely in the equation, right, for every 2 mole of Fe, you get 2 mole of FeCl3. Okay, so the mass of product form will be based on number of mole of the substance that you get lah. So in this case, they say that you get 0.1 mole only, right? So if you have 0.1 mole of Fe, you will get 0.1 mole of FeCl3 as well. So the mass of the product, you have to calculate the MR first. So MR of FeCl3 will be 56 plus, okay, 56 plus 3 times 35.5. So you'll be able to get, let me check and see, 56 plus 3 times 35.5. And you'll be able to get a total of 162.5. Then to get the mass, will be number of mole of FeCl3, which is 0.1 mole, multiplied by 162.5, you get 16.25 grams. So that's the answer lah, and you'll be able to get 2 marks. All right, that's pretty easy. C, table 3 shows the result when group 1 elements react with oxygen. So burn slowly with red flame, and the other one burn vigorously with purple color flame. So red flame here indicates the presence of lithium, and purple or lilac flame refers to potassium. So explain the reactivity difference in observation between A and D elements. So I think you can explain in terms of the position of the element lah. So based on atomic size. So you can say here, size of atom A is smaller than D. Okay, size of atom A is smaller than D. Then you say over here, it is harder for atom A to release its electron during chemical reactions. Okay, so that is one. They can say lah, the reason why is because this is because the force of attraction between the nucleus and the electron is stronger in atom A. Okay, so that'll give you enough explanation to score you 2 marks in total. Right, so the smaller the atom size, the harder it is to release the electrons because the protons in the nucleus are pulling the electrons towards itself. So to release that one valence electron out, it will be technically harder compared to a larger atom. And for D, B oxide is amphoteric in properties, suggests 2 chemical substances to show metal B oxide is amphoteric. Give a reason. So amphoteric oxides are technically the one that can react with both acid and alkaline substances. So I think that if you want to suggest 2 chemical substances to be used, I think you can use very simple ones like hydrochloric acid and sodium hydroxide. So you're going to just put here hydrochloric acid and sodium hydroxide. Then you get 2 marks already in this case. Right, and then of course, then I ask you to explain one more reason, right? Why you have to use these 2? Because you say that amphoteric oxides like oxide B is actually can react with both acid and alkaline substances. So you say here amphoteric can react with both acids or alkaline. I'll give you 2 marks, sorry, 1 mark extra. So 2 marks for the substance that you suggest, and then finally give a reason why. So therefore I got 3 marks over here. So that's done. So that's pretty much all for question number 8. Let's move on to question number 9 in section B. So the 8.1 shows 2 natural polymers. So we have one which is milk, and the other one is actually what we see in rubber. All right. So state the meaning of polymer. I think it's very simple. So you can say here is a long chain molecule produced by a combination of many monomers. Okay, so it's with here a long chain molecule that is produced from the combination of monomers. Okay, so state the monomer for polymer X and polymer Y. I think Y is X is supposed to be referring to the protein inside the milk. Okay, so protein has a monomer called amino acid. So you can put here monomer X is equals to amino acids. And then monomer Y is called isoprene for rubber. Okay, so then after that you get 2 marks for explaining what are the monomers of each substance. Okay, next. Polymerization process takes place between monomers in polymer X, and it produces polymer X and water. State the polymerization involved. So if you have water being produced, okay, in the process of joining the monomers together, we'll call that as condensation polymerization. Okay, so condensation polymerization. You get 1 mark over there. Nice, done. So I think that's pretty much very easy. Let's move on to the next question. So B, direct 8.2 shows the information about 2 types of plates. So we have one which is made up of cornstarch, wheat flour, soybean flour, and water, and is biodegradable. Made from the other one will be B, made from thermoplastics or thermosets, and then non-biodegradable. So choose the plate which can cause environmental pollution. Explain your answer why. So I think it's very obvious that it's actually B. Okay, so you can list down any harmful effects of B lah. So you can put here B because anything at all. Just put here the plastic. Material. Can cause flash floods, if it clogs the drain. Okay, we can also say that they actually produce microplastics which can affect the food chain. So you can put here also it produces microplastics which can end up in the food chain. And any other logical answers that you have in your mind, which means, for example, let's just say you don't want to talk about food chain, you don't want to talk about, the flash floods. So what else can you talk about? So you can say things like, it can cause a very long time for it to degrade. It will cause landfills to be filled up. Any one of those answers should be okay, okay? As long as you can answer that it's actually a problem for the environment. So therefore, you're able to score 3 marks here. Synthetic polymers are widely used in our daily lives, okay? In your opinion, state 3 characteristics of plastics that can encourage the whole usage. So I think it's very simple. First of all, plastics are better because they are light, okay? You can also say that they are cheap and easily available. Okay, others that you want to add inside will be things like waterproof, you can say that you can actually remain stable at high temperatures. So any one of those 3 answers can be used in your answer schema, okay? All right. And then for C, latex is collected in a liquid form. For processing, it can be left to coagulate and to be collected a day after it was tapped. So label a diagram of the rubber particles and explain how latex clumps when acid is added to it. So I think it's very simple. all we have to do is just draw a very nice picture. So how we normally draw this is very simple. You can just draw a circle, all right, like this, and then you can just draw wavy lines to show the rubber particles. Okay, and after that, you can just put a negative membrane just to indicate negatively charged means negatively charged membrane. All right, and supposedly they should repel each other, right? They should repel each other to the point where they bounce off each other because they have the same charges on the surface. So that's why they will not clump together. But the moment you add acid inside, it will neutralize the charge on the surface, and then when they bump to each other, it will crack open and allow the rubber particles to form together, to clump together to form this large group of particles. Then it will be coagulated. So how do we explain this in a very detailed form? You can just say that I want to give you very simple answers. So the first one you can just say here, the membrane, right? The protein membrane. Okay, the protein membrane is negatively charged. Okay, you say here, hydrogen ions are neutralizing the negative, okay, or will neutralize. Okay, will neutralize the negative charges of the membrane. Okay. And after you just say that, the particles can now collide against each other. Okay, when they say collide against each other means that, after they neutralize the charge already, right, then they can come close to each other, right? Then they will collide and it will cause the membrane to break. And then after that, the rubber particles can actually mix together. So you can see in the next part over here, you can just say that the protein membrane will break or crack. Okay, other one. And you can see that the rubber polymer will then stick to each other. So the rubber molecules will combine with each other or will clump together. Or you can use the word coagulate. Together. All right. And cause coagulation. So any one of these should be correct. If you write everything in detail, then you'll be able to get 10 marks straight away. Okay, remember that. Remember that your drawing also gave you marks because I asked you to draw, right? So if you ask you to draw an exam, then you get marks for the drawing itself. So in this case, I say 2 marks for the drawing and the explanation points later on. If you hit all of the keywords, you should be able to get 10 marks in total. Okay, so remember, it's very simple. If you don't remember how the rubber particles can mix together, you just remember this. Okay, so on the surface of the protein of the rubber molecules, there are all negative charges. So if you put acid inside, acid H plus will go and kacau, and it will actually go and disturb. It will neutralize the charge of the surface of the protein. And then after that, when they come close to each other, the protein membranes come close to each other, they won't be able to repel anymore, but they'll collide with each other, sit head on, and then you'll crack the membrane. And then after that, what happens is that the rubber molecules will come together, clump with each other, they'll coagulate together, and then it will be solid after that. So that question itself will give you 10 marks in total. Okay. All right, let's take a look at the next question. So number 10, a student carried out 3 sets of experiments by using 1.3 grams of zinc to investigate the factors that affect the rate of reaction. So the time taken to collect 100 cm cube of gas is recorded. So over here, you got 50 cm cube of 0.5 mole per dm cube of sulfuric acid with zinc powder. Second one, you have same concentration and volume of sulfuric acid with zinc granule. So one is powder and one is granule. And then the third one over here will be 50 cm cube of 1.0 mole per dm cube of zinc powder, okay, reacting with that. But what changed here is your concentration of the acid, okay? Concentration of the acid is changed. Then you see that the highest rate of reaction is when you use, highest time taken for the gas to be collected will be the second set experiment. And the fastest is technically the third set, okay? Right, calculate the rate of reaction for set number 1, and this is assuming that it is, what's it called? It is actually average rate of reaction. So rate of the reaction in for set L, I don't think it's set L, I think they're referring to, set L. I don't think it's set L. I don't know. I think there's something is wrong with that. So never mind. We will just assume that it is set number 1 or set number 1. So I say wrongly. I thought it's L. Okay, so set number 1. So that will be a total of 100 cm cube gas collected over a period of 80 seconds. Okay, so rate will be 100 cm cube divided by 80 seconds. So that'll be 1.25 cm cube per second. Okay, so that's 1 mark. And after that, says here, zinc, when react with sulfuric acid to produce zinc sulfate and hydrogen, maximum volume of hydrogen gas produced is in the set 3. All right, and then after that, you can see here, write a balanced chemical equation for the reaction and calculate the maximum volume of hydrogen gas produced in gas 3. Okay, very simple. So the first one will be zinc added to sulfuric acid. I think that's a very common one. And you will get zinc sulfate plus hydrogen gas, okay? So right now what we say here is that imagine you want to get the maximum volume of hydrogen gas, okay, now. How much is the number of mole? Okay, very simple. Let's take a look at the number of mole of acid for complete reaction. So acid here will be 50 and 0.5, isn't it? What is for set 3? Okay, sorry, 1 times 50. So we use the formula of mv over 1000 to get number of mole. And I think that's pretty simple as well. We'll take 50 times 1, or should I say 1 times 50 divided by 1000. What should we get? So you got 0.05 mole. Okay, 0.05 mole. All right, so now 0.05 mole of acid is being used, and also zinc, of course. But we want to make sure that there's no excess substance. So let's take a look at the top part also. It says here we have 1.3 grams of zinc. So we see closely, right now it's a 1 to 1 to 1 to 1 ratio. So it's all 1 to 1 ratio, but I want to see whether it is anything that's in excess or not. So this one is referring to the number of mole of H2SO4 being produced. Okay, so next one to calculate number of mole. Okay, number of mole of zinc, which in this case, it says that you already have 1.3 grams divided by 65. you'll get 0.02. So this number, okay, that number and this number does not relate to each other. So therefore, we'll say that sulfuric acid is technically the limiting reagent, okay? 0.02 to 0.5. Oh, sorry, the limiting factor here is zinc because it's supposed to be 1-to-1 ratio, but you don't have enough zinc to react completely with 0.05 H2SO4. So this is your limiting factor. So we're going to follow that particular number of mole to get our answer lah. So right now, assuming that we have this one as our reference, then we know that every single substance here will also have the same number of mole. So right now, the volume of gas being produced will be 0.02 multiplied by 24 dm cubed per mole. And I will be able to solve it and get our answer. And the answer is 0.48 decimeter cube. Or should I say 480 cm cube. So both are correct, technically. So once you get everything correct, it should be able to give you a total of 5 marks in this question itself. Okay, all right. By referring to the collision theory, compare the rate of reactions in set 1 and set 2 of the experiment. I think it's pretty simple as well. So between set 1 and set 2, what we're studying here is actually the size of the particles. Okay, one is powder, one is granules. Those sizes being compared. So I think we will use a separate page for this because I think it's too long. So that's what we saw, right? In this case, what was it just now? They said that between set 1 and set 2, so surface area lah. So for set 1, you can say that the rate of reaction is, the rate of reaction off, okay, off. So you see here, the time taken for the gas to be collected between 1 and 3, like 3 is a higher one because why? 3 takes a lower time to get the, 1 and 2, right? Okay, 1 and 2 first lah. So 1 and 2 here, I would say that there's a larger surface area for zinc powder to react with the acid compared to zinc granule. So that'll be your answer lah. So you see over here, the rate of reaction of set 2 is slower or lower compared to set 1. Okay, that's the first one. Then you see over here that the total surface area total surface area of the zinc powder is greater than in set 2 or greater than total surface area of zinc powder is greater than total surface area of zinc granules. I think that would be a better answer. Then zinc granules okay, so you see over here that more collisions can happen, or the number of collisions can increase. Okay, I don't want to wait lah. Number of collisions will increase. Then you say that this results in a higher number of rate of reaction lah. Okay, so this results in a higher rate of reaction. That's one. Okay, so usually questions like this, if we see properly, they only carry like around 4 to 5 marks for each. So if you answer every single point, this should be done, no problem. Okay. So we compare the rate already. We also talk about the surface area and also the number of collisions, as well as the number of, oh yeah, I missed that one, which is number of effective collisions. So you can also say that this results in a higher rate of reaction because more effective collisions has occurred. There will be more effective collisions. Done. But then know about set 2 and set 3. So set 2 and set 2 is set 2 and set 3. Oh, set 1 and set 3. So set 1 and set 3 now you're using a different concentration of acid. So the higher the concentration, the better lah, in terms of rate of reaction. Okay. So you can also explain technically set 3 has a higher rate of reaction than set 1. Okay, so you say here rate of reaction of set 3 is higher than set 1. They'll give 1 mark already. So what I did was on top here, right, like an essay form, but it's not in point form. The second one over here, right, in point form lah. So it's easier for you to see the styles that we can use. So technically speaking, you can actually use point form for your answers lah, but write neatly, of course. Okay, don't simply write. So rate of reaction of set 3 is higher than set 1. Very simple. You'll explain why. So you say that the concentration of ions or H plus ions, okay, H hydrogen ions in set 1, set 3 versus set 3 is greater compared to set 1. So you say this results in more collision. Just 2. Okay, this results in more collision between the reactant particles. Okay. And then you say more effective collisions will occur between the reactant particles to form products. And I think that's pretty much, that's it. Done. Okay. So if you can explain all those in detail, I think that should be enough for you to score a total of 10 marks for comparing the rates of reaction by using collision theory to explain. So I think very crucial is that you must be able to tell talk about the concentration of ions, talk about the frequency of collision between the reactant particles, and also we need to mention the effective collisions between the reactant particles, which results in the formation of products, and then only you'll be able to get all the marks. Okay, so that is pretty much for this particular question B. If you write everything correctly, you should be able to get a total of 10 marks in total. Okay. But let's go to C. Ali wants to grill satay on his 17th birthday celebration. So based on the knowledge and rate of reaction, state 2 factors to ensure satay cook faster. So what happens here is that, using what you've learned in your rate of reaction, the question actually wants you to state 2 main factors that can actually ensure that the satay can actually cook faster lah. So I think 2 factors that you can use to make sure that the satay can actually cook faster will be by either increasing the temperature of the burning charcoal, because you see the charcoal over here, right? So either you actually increase the temperature of the charcoal by maybe, for example, fanning it, to make the sparks become brighter, or to make sure that the charcoal actually produces this more amber. More amber means technically becoming more amber means there's more heat being produced lah. All right, to increase temperature, or you can actually cut down the size, or you make the size of the chicken become smaller lah. All right, so that's the only way we can actually increase the rate of reaction. So very simple, you can just put here by increasing temperature, that will be the first answer, right? By increasing temperature, or you can actually decrease the size of the chicken. Decrease the size of the meat lah. Or use smaller pieces of meat also can. Okay, that will actually give you a higher rate of reaction lah, based on what you have learned in your rate of reaction. Okay, then let's take a look at the next question. So based on answer, you see choose one factor to explain answer. So this is based on the collision theory lah. So perhaps maybe what we can say here is that maybe we choose the smaller pieces of chicken. So you can just say that a larger surface area can be produced so that the meat can actually react with the heat, and that can actually increase the rate of reaction. So here we can say is that when the size of the meat is smaller, the surface area, or just say the total surface area, the total surface area of the meat increases. Then you say that the heat can then react with the meat much more faster, or much faster lah, okay? To cook the meat lah, okay? So that will be something that you can explain to increase the rate of reaction to where the meat can actually cook faster. So more heat present means easier to cook. So when you cut down the pieces of the meat to smaller pieces, the total surface area that's exposed to the heat will definitely be much more greater lah, much more larger. So that's the answer. So let's move on to section C. Number 11. Table 5 shows the pH value of H2X, H5, and Hz, and the concentration of the acid are 0.01 mole per decimeter cube.
H2X produces a pH value of 1.7. HY is about 2, and HZ is actually 5. So I think if you see closely, H2X is actually a much stronger acid compared to the other two. HY is also considered as a strong acid because it has quite a low pH value as well. But HZ is about 5, so it's actually quite high. So I'm guessing that probably H2X and HY are technically strong acids, but HZ is actually a weak acid. And also, if you notice, right, H2X is a monoprotic acid. Sorry, H2X is actually a diprotic acid, and HZ is actually a monoprotic acid. Okay, so that's just to keep in your mind lah. So A1 here says that H2X is diprotic acid, while HY and HZ are monoprotic acid. Suggest the name of H2X, HY, and as well as HZ. And I explain why the pH value of HY and HZ are actually different. Okay, so this is actually quite simple. Since I explained to you just now already regarding the identity of those acids, so we can actually predict them quite easily. Since H2X itself is a diprotic acid and is also a very strong one, then we'll say that this is actually sulfuric acid lah. Okay, diprotic and also strong lah. So therefore, this will be sulfuric acid. This is referring to H2X. And then HY will definitely be anything between hydrochloric acid, if you like, because there's also a monoprotic acid, but it's strong. Or you can also choose another one, which is nitric acid, because two of these are monoprotic acid, but they are actually strong. So you choose either one of those lah. Okay. And then HZ is a weak acid and also monoprotic. So I think we can choose ethanoic acid over here. That's the most common one that we use. So with these 3 suggestions, I think you get 3 marks already. And they're asking you to also explain why that the pH value, okay, why the pH value of HY and HZ are technically different. So it's all about the concentration of hydrogen ions. So I think what you can say over here is that HZ is a weak acid which only ionizes partially in water to produce lower amount of H+, while the HY has a higher amount of H+ is because they ionize completely in water. Okay, so very simple. So HY you can put here, ionizes completely in water to produce high concentration of H+ ions. And then for HZ, you can put there, ionizes partially in water to produce lower concentration of H+ ions. So I think that's something that we can actually talk about, because if you remember, the pH value is calculated based on the negative logarithm of the concentration of H+. So that tells you that when you have a higher amount of H+, the pH value will be lower. So the lower it is, the stronger the acid. And that's how we can explain it lah. So if you explain everything correctly, or you can also explain that HY is actually a strong acid, while the HZ is a weak acid. And then only proceed forward to explain what strong acid and what weak acid basically means. And that way you'll be able to score 6 marks in total, including giving suggestions of what those H2X, HY, and HZ acids are. Let's move on to the second question. In another experiment, 25 cm³ of HY, 1 mole per 1.0 mole per dm³ is needed to neutralize 25 cm³ of sodium hydroxide solution. write the chemical equations, and then calculate the concentration of sodium hydroxide in the experiment. Okay, the first things first, chemical equation. So for the chemical equation, right, you have to use HY. Although we have already suggested that it can be HCl, but we cannot actually write it down specifically. In this case, we're going to use HY, for example. So to write the balanced chemical equation, you can just write the HY plus NaOH. We will completely neutralize it to produce NaY plus H2O. Okay, so that's the balanced chemical equation there. And then it says that we have 25 cm cube to 1.0 mole per dm cube, and then 25 cm cube of sodium hydroxide. So since it's a monoprotic acid and a monobasic base, so 1-to-1 ratio, isn't it? Right, 1 mole, 1 mole. So we know that 1 mole of H plus will neutralize 1 mole of sodium hydroxide solution. Then you'll be able to get 1 mole of water lah. So since it's a 1-to-1 ratio, we're going to compare the number of moles straight away. So what I can do over here is you can just put M1 V1, M2 V2. Okay, because what I'm going to do later on is to compare number of mole, right? The mole is actually 1-to-1 ratio. So M1 V1, right? M1 V1 is equals to M2 V2. So right now what we're going to find out is V2, right? So make V2 a subject. So that would be M1 V1 divided by M2. Although this formula is exclusively used for dilution of solution, however, in this case, because it is 1-to-1 ratio, we can actually use it directly. Technically illegal, but it's a shortcut for us to get the answer lah. I will say that. Okay, so in this case here, you just substitute the value in. We have 1.0 times 25 divided by 25. So if you were to cut, you realize that the concentration of the sodium hydroxide is the same as the acid, which is 1.0 mole per dm cube. So therefore, and let's put there concentration of NaOH is equivalent to 1.0 mole per decimeter cube. You get 4 marks. That's it. Right, so that's pretty simple. If you want to do the traditional way, the long way, you can then compare number of moles by using the formula of MV over 1000. Right, and if you combine number of moles, then you realize it's 1-to-1 ratio. So that's why we can actually proceed straight away by using this one lah. Okay, but sometimes students are a bit uncomfortable in doing that. Perhaps they want to show everything in a more traditional way or a more proper way. You can straight away just use this method lah. However, if you want it to be fast, you're going to make sure one thing, which means you must have a monoprotic acid and a monobasic base. Then you can straight away jump and use this formula over here. Right, otherwise you cannot. If you say, for example, you have a sulfuric acid and a sodium hydroxide, then the ratio will change. Then you have to use the traditional method of using that particular formula, MV of 1000, then compare number of moles, then only you get the concentration. Okay, all right, let's move on to the next one. Number 1 shows a jellyfish. So the sting of a jellyfish is alkaline and causes pain. Suggest one substance that can be applied to the skin to relieve the pain without causing further injury. So I think we can use, since it's alkaline in nature, we can use something which is acidic. So I can suggest that we can use vinegar actually. So the one substance that we can use over here will be vinegar. But you can choose anything else that you like. All right, for example, orange juice or lime juice, anything that's acidic lah. Okay, so vinegar, lime juice, orange juice, lemon juice, anything lah. All right. So then after I explain why lah. So for example, if we choose vinegar, right? You can say that these are all weak acid. Okay, so you can say here vinegar is a weak acid which can react, or you can say can neutralize the alkaline sting of jellyfish. So that's one. And then another one, you can also explain like how does it work. I think in this explain that because it is a weak acid, it doesn't actually corrode the skin or doesn't actually injure your skin. So you say here there will be, or you can say this, the acid is not strong enough to cause any skin injury. So that would be another one thing I explain to make sure that it actually works. All right. And this one you mentioned weak acid, right? So it's a weak acid, it can neutralize the alkaline stink of the jellyfish, and it's not strong enough to cause any skin injury. So there'll be like 3 reasons why you left technically. So you said that one is the weak acid. How does it work? Neutralize the alkaline sting. Okay, what about that? What else about that? So you say that it's not strong enough to cause any skin corrosion or injuries. I think that should be enough ready to explain how does it work in this case. All right, so that's pretty much about the B. So go on to the next question. All right, C. A student carries out a test to investigate the properties of ammonia when dissolved in methylbenzene and when dissolved in water in 2 different test tubes as shown. So methylbenzene is actually a type of organic solvent, and since ammonia itself is a covalent compound, it should be able to dissolve inside methylbenzene as well. But only when dissolved in water, ammonia will be able to show its alkaline properties, because if you see ammonia, if it dissolves inside the methylbenzene, it's just a mixture. But the moment you dissolve ammonia into water, for example, right, and then you'll be able to get ammonium ion, and you'll be able to produce hydroxide ions at the same time. So that tells you that when it produces the hydroxide ion, it will be able to show some sort of a alkaline property lah. Okay, so that's the idea behind it. So it says here, predict your observation of the color litmus paper in both test tube A and B, explain your answer. So we'll just say that in test tube A, I'm just going to write in point form for you so you can understand easily. Yeah. All right, if I write everything in essay form, then you'll be very confused. So in this case, again, you can put here the first point. No hydroxide ions are produced. Okay. No OH minus ions are produced. Does not show any alkaline property. And then you can say that litmus paper remains red. Okay, litmus paper remains red. And then for the other side, you can also say that ammonia ionizes partially. To produce partially in water, I think you must be able to explain it. To produce OH minus ions. And after that, you also can explain that presence of OH minus can exhibit or to display or to show alkaline properties. So what will happen over here will be that the red litmus paper will turn blue lah. Okay. So I think 3 points to explain how and why, ammonia is inside methyl benzene can or cannot show its alkaline properties versus in water. I think we've already explained every single thing in detail. So you should be able to score full marks for this question because it's only 6 marks. So you explain in terms of the presence of OH ions, whether it is present in the solution or not, based on what ammonia is dissolved in. So again, ammonia dissolved inside methyl benzene is normal, it can dissolve there, but it will not be able to produce OH minus, so therefore they will not be able to show some sort of a alkaline properties. But for the right side, you see here, right, ammonia ionizes in water, it does produce hydroxide ions, and then the presence of hydroxide ion can actually exhibit alkaline properties. So you can show its alkaline properties because of the presence of hydroxide ions. And because of that, the red litmus paper will be able to turn blue. All right, so I hope that it actually explains everything and you'll be able to understand that. So I think that's the end of the question paper. I hope you guys have learned something that can help you in your exams or perhaps to help you do some revision. So I think that's all from me this time. I'll see you guys in the next video. Thanks, guys.